Hello, everybody. So today we're going to be going over the problem for the momentum explainer video. So let's start sharing this. I lost. There it is. All right. So I got problem 4 from Expert TA, and it says that a massless spring with a force constant of 196 connects a wall and a block of wood. The system is initially at rest with the spring unstretched. The block has a mass 54.8 grams and is able to move without friction on a table. The gun is positioned to fire a bullet of 5.8 grams into the block along the spring axis. After the gun is fired, the bullet gets embedded in the block and the spring is compressed at maximum distance of 0.87 meters. And then the problem that the question asks is in meters per second, what is the speed of the bullet, V, before it enters the block? And so as always, you want to start these problems with a picture of some kind to help you. So I have drawn it right here. And so basically, we know our knowns are basically the mass of the bullet, the mass of the block, and then the force constant of the spring, as it says up here, is right here. So I just put it by the spring just for reference. And then the distance the spring compresses is right here. So basically for this problem, you have to think of it as kind of a two-part process, if you will. Like there's two parts to this whole process of the bullet getting embedded in the block. That's basically this part here, when the bullet hits the block, and then the block will move backwards and compress the spring, as the problem states. So there's kind of two things happening in this problem. So because of that, for this problem, we'll have to use both conservation of energy as well as momentum. And we'll have to relate those two together in two steps of like an equation, basically. We have to find one thing to find the next thing using both conservation of energy and momentum. And then also one of the pitfalls I fell into this problem and is the reason I really struggled on the homework and couldn't figure out why I was wrong, is because the units of momentum are kilograms per or times meter over seconds. So the grams in this problem have to be converted to kilograms for this problem to come out correctly. And in most cases, and most of our like physics homework and stuff, units just work out kind of on their own, but this is a special case where you have to make sure you convert that in your calculations for it to come out correctly. So first, we need to find the speed of the bullet as it impacts the block. Therefore, we need V final. So for this section, we can use the conservation of energy. So we will use this equation here for the kinetic energy, 1/2 times the mass of the block plus the mass of the bullet times V squared. And then also here, another pitfall, another thing that can go wrong is you want to make sure you're using spring for potential energy and not potential energy for like height or how high something is in the air, because obviously it's a spring, as you can see right here. So you have to make sure to use the equation for the potential energy of a spring. And because the bullet energy is transferred to the block, the energies can be set equal to each other due to energy conservation. The energy of the bullet hitting the block has to equal the potential energy that is created after. So you set them equal to each other and you can rearrange just like this. And just like that previous pitfall, make sure to convert your kilograms or your grams to kilograms. And then you should get something around here if you have numbers like I do. And then, so next we need to look at the conservation of momentum. And because momentum is conserved, the momentum of the bullet must equal the momentum of the block and the bullet. So you can set them equal to each other, just like we did for energy conservation right here. And then you will solve for velocity of the bullet right when it actually collides with the block, basically, or before it enters the block, basically. So you put it into this equation right here, and you can rearrange it for V the bullet. And if you do it all correctly, you will get 502.23 meters per second. Okay, let's stop sharing here. All righty. Thank you for watching this video, and I hope you enjoyed.